multinational provider of communications and technology services. The company offers several types of services such as software and infrastructure information and communications technology. It also provides services for telecom operators and other traditional telecommunications as well. So we are currently focusing on a certain part of the technical support group within J&J Telecommunications. Because it's such a wide multinational company, we didn't have enough time in order to solve all their problems. So we focused on a certain group. It's a support center for technical engineers that provide technical support to each site for all the field engineers that are currently on the site. So the current situation at J&J is that technical engineers are not able to meet the demand of field engineers, and also the field engineers' wait time is currently anywhere from 15 minutes to up to 2 hours. This also causes huge delays in productivity. It also lacks customer satisfaction, and also another keynote is that there is only currently 25 technical engineers available to support them at the time. Another huge factor of the current situation is that field engineers can change the time of service at any time with no penalty whatsoever in doing so. Moving on to the challenges. Some of the challenges that we faced to solve our model was that we were not able to add more employees. So J&J specifically told us that we had to allocate between the 25 employees. And the third note of our challenge was as well that not enough data was provided by J&J. So to be specific, the data that we were looking for to be able to put into our model was the number of calls per hour that they were receiving within the support center, and as well the duration of the support call that each tech engineer would take to support the field engineer at the time. And also, lastly, the last challenge that we faced was trouble gathering data. So we were sent off to a certain engineer, and that engineer would send us off to a different engineer, and basically we were going in circles trying to gather our data. So that was another factor of our challenges. So moving on to the assumptions that we made. So the first assumption that we did was we created 8-hour shifts within the whole day. So basically we started at 12 a.m., moved on to each hour, creating 8-hour shifts within the whole 24-hour period. We also created 3 different types of scenarios and 3 types of demand peaks within each scenario. So the first demand peak time was from 6 a.m. to 10 a.m., and then 10 a.m. to 2 p.m., and 2 p.m. to 6 p.m. And we also assumed random number of calls each hour. So by that we meant that we created random incoming calls within the tech support group that would come in within each hour, and supposedly each engineer would be supporting and taking. The approach towards the current situation. So first and foremost, we defined the problem. We also gathered all the given data that was given to us by J&J, and we decided to go ahead and create a scheduling model. So from that, we also, as stated previously, we decided to create several scenarios to help us give a feasible model. So now I'm going to pass it to Almuhanad to explain the scheduling model.
Okay, as Laila said, we based on J&J, based on data given to us by J&J, we decided to do a scheduling model that would help the call center support the maximum number of incoming calls possible with detecting shortage in staff, if there is any. So here this is our scheduling table that we created with 16 shifts distributed over the 24 hours. So moving on to the decision variables. So in this model, we created 2 types of variables. The first one is XI, which is the number of employees in shift I, and SJ, which represents the shortage in number of employees within each within our J. So here are some example of our variables. So for the constraints, we have two types of constraints. The first one is our capacity constraint, because as Laila said, we only have to work with those 25 employees per day. And we also, the second type is the demand constraints. So for the capacity constraints, we have 16 of them, and for the demand constraints, we have 24 constraints to cover all demand throughout the day. So since J&J Telecommunications, since the number of calls that J&J Telecommunications receives every day, they differ from day to day, along with the fact that they don't have a tool to calculate the number of calls received every day. So we decided to come up with three scenarios of possible demand to determine the maximum number of calls that those 25 employees can serve. So here for the first scenario, as you can see here in the graph, the x-axis is the number of calls, the y-axis is the number of the 24 hours of the day, and we decided here to set the peak from 6 to 10. So that means in those 4 hours they receive the highest number of calls. So after running scenario 1 model, we got those results. So for example, in shift 1, there should be 4 employees, 2 in shift 3, 1 in shift 6, 8 in shift 7, and so on. The same thing with scenario 2. Again, we did the same thing. So we set the demand peak from 10 to 2, and after running the scenario 2 model, we got those results. So they are like kind of different from each other. And the purpose we are doing this is to show how the results is going to look like, keeping in mind the different types of demands. Because we believe that those times are the most times that the call center will receive the most of the calls.
And finally, to give our recommendations. So if this model is used, we receive the result that the maximum number of support calls within the 24-hour period in all 17 shifts would be about 180 calls. And this is assuming that every employee takes 1 call per hour, which would obviously be more than that, but basically just on the random model that we created with the incoming calls, this is what the maximum number of calls allowed within the 24-hour period would be. Other suggested alternatives that we came up with as well from working with J&J was that maybe it would be possible to create an app to communicate with the field engineers, because they have the situation where field engineers can, for instance, if they're scheduled at 3 o'clock, they can show up at 5 o'clock. So this app would possibly give a notification sent out to the supervisor that's on call, and to be able to schedule his staff accordingly. And also, another suggested alternative was to keep track of the field engineers that constantly change the scheduled times in order to see who or which groups are the ones that are causing such difficulty in the field, the tech engineers to be able to support everyone. And then finally, we'd like to thank John Cushing and Jason Staggett from J&J, because they were the only ones that would honestly get onto their employees to give us the data whenever we needed it. So, and also Dr. Sims and Professor Hassa for all their support and input. Are there any questions?
So on the random calls, did you decide how to randomize them?
Okay,
And when and where?
okay, so off of that, our reference, Mr. Jason Saget, we spoke to him on regards to the customer, on approximately how many calls they would get during the day. So we kind of were close to the number given, the number that he gave us. We played around with that, adding maybe 2 or 3 or 4 just to create our model. But we used our resources in order to get that.
So your models had, you had 3 scenarios, 3 different scenarios that had 3 different demand peaks, right?
Yes.
So do you know how realistic any of that is?
Well, within the telecommunication industry, it could be, those times are realistic because you could, depending on the projects that are going on, or depending on the different sites that need troubleshooting, or different resets sent out, or different alarms or technological software is set up, it could be realistic because these workers work around the clock. So it's not realistic to us. It might be unrealistic when someone's out on call or during the shift at 11 p.m. But to them, it's not. There could be someone working on the site and needing support at that time.
Other questions? Yes?
What time did shift 1 start? Was that midnight?
Yes, it starts at midnight.
I was surprised it told you to pull out like 6 people at midnight.
Yeah, because so basically on that, when it told us to put 6 people on midnight, is because we set the peak time at supposedly those hours. I think it was, what was one at midnight? It was 10 to 2.
That's okay.
Yeah, but our model
Seems like you're featuring the middle of the day and they have people start at midnight. I didn't quite understand that.
yeah, so basically.
Because the equipment can't be taken down during the day, so all our work starts at midnight, basically.
So it just depends on the number of calls that we did. So probably it told us to put it that because in our model, when we set up the random number of calls, we put, for instance, 20 calls at 10 p.m. So they had to go off of that. So that's what we created that schedule.
And we did the model assuming that every employee can serve 1 call per hour. So that's like an average. We did an average. Like every employee can serve one call per hour.
And that's another thing that we have to take into effect, that each call that they take, we can't have, we even tried looking for trends of the duration of calls to setting up, for instance, a call may take 15 minutes or 17 minutes. But because every call differs, we failed to find that trend. So we had to go and assume that, you know what, let's just say that 1 call that each tech engineer takes, about an hour to support.
Thank you.
Yeah.
All right, thank you. Okay, what I need from y'all is your filled out